All right, we're going to go ahead and talk a little bit more about arcs, and specifically we're going to talk about arc measures. Now I'm highlighting measures because measure is different than a length. So we're going to talk about lengths later on, arc lengths. Arc measures are the degrees. Okay, so when it comes to the minor arc, so the smaller than a semicircle arc, the arc measure of that minor arc is always the exact same as the central angle. And then for the major arc, you can find the major arc, like ADC, by subtracting 60 from 360. So you get the major arc is 300 degrees. The measure of a semicircle is always 180 degrees. That should make sense since the semicircle is half of a full circle and half of 360 is 180. Also, fun fact, when we draw an angle and we indicate the angle, we always actually draw an arc in there. That's because we are imagining there is a circle along this thing. So when we look at circles, it's like we've zoomed in to this little section of the circle. So that's why the measure of the arc is the same as the measure of the angle. So let's go ahead and use that information. Before we use that information, I forgot about the arc addition postulate. That just means if you know the measures of two arcs, but you want to find the measure of the bigger arc that includes both of them, you just add them together. So like if this were 30 degrees and this were 40 degrees, then the measure of arc ABC would be 30 plus 40, which is 70. So that's all that's saying. It's pretty easy. So let's go ahead, go to example 4 first. Before we do any of these and indicate any of those, we're going to go ahead and just label our picture so that we know what each of the arcs, the measure of each arc is. So measure of like arc BC, for instance, is 42 degrees. This one right here, the measure of AD is 90 degrees, so those are the two given to us. Now, anything that looks like a diameter, we can assume is a diameter. So that means DAB, arc DAB is actually a semicircle. And if you have one right angle on one side, you have a right angle on the other. So they're both perpendicular, which means this is also 90 degrees right here. Which leaves us to our last arc, CD, this a minor arc CD we've got to find. And there are two ways you can do it. The whole circle is 360 degrees, so you can do 360 minus all of those. Or, since we're just looking at half the circle right here, we could go ahead and just do 180 minus 42, and you get that this right here is 38 degrees. So let's go ahead and find each of these. So AB is right here, and that's 90 degrees. Let's go to CD. So CD right here is 138. Let's go to AC. So minor arc AC is right here. Since it didn't have a third one, so technically you could have an arc going this way from A to C, but because there were only two letters, that's why I knew it was the minor arc, or the smaller one. Okay, so just as a reminder. So that means I just need to add 90 plus 42, and you get 132 degrees. So then we're going to go ahead, I'll use orange. ADC, so I'm going to go, since there's three, I'm going to go in the order it shows me. So ADC right to here. So that whole region. So I can find that by adding the two arcs. So 90 plus 138, and you get 228 degrees. And then our last one, last but not least, we got ABD. So this is a major arc again. So I got to go the order it shows me. So AB all the way to D. So that whole section. Now there are two ways you could approach this. You could add all three of these angles together. Or I actually think it'd be easier, since there's one that's on the outside, you could go ahead and just subtract 90 from 360, which I'm going to do it that way. So you get 270 degrees. Let's go ahead and take a number 5. Same idea. So let's, oh, that's as far as I can go. Let's go ahead and just start marking everything. So this 22, this is the arc, minor arc TS is 22 degrees. So just as a reminder, that means inside here is also 22. But this one's going to be a little more exciting. I'm going to indicate the diameter, which is right here. Since that's the diameter, QRS is, arc QRS is actually going to be a semicircle. So I can go ahead and find this angle right here by subtracting 85 from 180, because a straight line forms 180 degrees. So I got 95 degrees. Likewise, on the same side, or on the opposite side, we can do the same thing, but this time we're going to subtract 22 degrees, and that will give me 158 degrees. I like to fill in the whole thing. Now that I've filled those in, I'm going to go ahead and put them on the outside. So that's 85, that's 95, that's 22, and then this one, let me erase this stuff so we don't get thrown off. This one is 158. Okay, so let's go through them. So minor arc SR. So that's this one right here, minor arc SR. That one's easy, it's just 95 degrees. Minor, or the major arc QTS. So QT all the way to S right there. That one's easy since it's a semicircle. It should just be 180 degrees. Then we've got QS all the way over to R. So that's this one right here. So once again, a quick trick. You could add all 3 of those together. Or, since there's only one missing, I'm just going to subtract that one missing angle from 360, and that will give me 275 degrees. Alrighty, now we're going to go to RTQ. Now this is starting to get a little messy, so I'm going to erase some of this. So RT all the way to Q. Now guess what? QSR and RTQ are actually going to be the exact same lengths. I don't know if you noticed that based on how I drew it. So once again, we should get 275 degrees because it's just missing that 85 degree angle. And then last but not least, let's go ahead and do minor arc RT. So that's this one right here. So R all the way to T. Now it's minor, so I can't make it really big. It can't be bigger. And that one, you just do 95 plus 22, which gives you 117 degrees. And there you have it. So if we go ahead, I'm just going to talk about these last few theorems. So the congruent circles theorem just says if your radius length of 2 separate circles are congruent, then the circles are congruent. They're the same size. Easy as that. Congruent central angles theorem. Well, if you look at just these central angles, we know that these are vertical angles right here. So all this is saying is if you have central angles, that means you have vertical angles. So the vertical angles will be congruent, but then also the arcs will also be congruent since they're congruent to the vertical angles. And then last but not least, all circles are actually similar. So I can dilate any circle I want, and I can make it bigger or smaller and map it to any other circle anybody gives me. They're all similar. So there are some other examples in these notes, but I'm actually going to go ahead and skip them. I think this is plenty. So let me know if you have any questions. Thanks.